Okay, now we're ready for problem 7 of this review. 7a says find both one-sided limits at x equals 3 and then determine whether the two-sided limit exists at x equals 3. All right, let's write this down and we'll talk a little bit. So this is a piecewise function where f of x is 2x minus 8 if x less than 3 and f of x equals negative 2 if x greater than or equal to 3. So really what they're wanting to know is, here's what they're wanting us to do. They're wanting us to find the limit as x approaches 3. However, we want to approach 3 from the less than side. In other words, as we approach 3, you have a choice when you're taking the limit as you approach a number. You can approach it from the lower side. In other words, if I'm approaching 3 from the lower side, I can think about putting in 2.9 or 2.95 or 2.99. In other words, I'm approaching it from the lower side. We denote that with the negative. But then we also need to look at approaching the limit when x is approaching 3 from the high side. In other words, you can think of plugging in x as 3.1 or 3.05 or 3.01. In other words, you're approaching it where the number is a little bit larger. Now what happens is, normally when you look at a limit, you really have to check and make sure that no matter which side we approach it from, the limit's the same. So what we're going to do here is we're going to look at each limit separately as we approach it from the two sides. And then if it turns out these two limits, they're the same, then we have an expression where we can take the two-sided limit. But they may not be the same. Let's just go and do it, and maybe it'll be clear. So I'm going to take, first of all, this first one, I want to approach 3 from the low side. In other words, the numbers have to be a little bit less than 3. So when I go look up here, I have to figure out which expression I should use. This first one is to be used when x is less than 3. And since I'm approaching 3 from the low side, my value of x is always going to be less than 3. So I have to use this first equation. So basically I have to take the limit as x approaches 3 from the low side of 2x minus 8. So you plug in 3 for x, you get negative 2. So when you approach 3 from the low side and take the limit, you get negative 2. Now let's see what happens if I approach x from the high side as I get close to 3, but approach it from the high side where all my numbers are a little bit larger than 3. Well, if I go to my function, when the numbers, the values are greater than or equal to 3, you end up using the second expression. In this case, there's no math to do because they said just go ahead and the limit is negative 2. So what you do is, when you take the positive and negative limit, if they happen to be equal, if they are, then you can end up saying actually the limit as x approaches 3 of f of x is negative 2. In other words, if you approach a limit from the low side and approach a limit from the high side, and you get the same result, then in a sense this is like the two-sided. It just says the limit as x approaches 3 is negative 2. And to have a true limit, you have to get the same limit whether you approach it from the low side or the high side. And that's what we've proved here. If you approach it from the low side, you get -2. If you approach it from the high side, you get -2. Therefore, just the normal limit is -2. So this is A. Let's see what B is. It's another piecewise function. This one says f of x is x squared if x less than or equal to -1 and f of x equals x if x is greater than -1. Now we need to know both the low and the high limits when x is -1. I'll write them both out here. Whoops. So this first one says, let's go look at the limit of f of x. I'm going to be approaching -1, but I'm going to be approaching it from the low side, right? So like -1.1 or -1.01. So first of all, if I go to my function, which one do I use? Since this is less than -1, looks like the top expression, because this says this is the expression if x is less than or equal to -1. So for this one, it's x squared. Now if I put in -1 for x squared, looks like it's 1. Now if I approach -1 from the high side, when the number is greater than -1, the piecewise function says that the function is x. And now if I plug in -1 for x, I get -1. And now I look at the limits from the low and high side. They are not the same. So we say that there is no two-sided limit. You only have a two-sided limit when the low limit and the high limit are both the same, like what happened in this earlier problem. Since they're both a -2, we actually have a limit. But here, since it's 1 and -1, there's actually no limit. All right, number 8. Some problems on continuous functions and continuity. Can be a little confusing at first, but actually hopefully you'll see that it's not really that hard. It says for each function below, determine if the given function is continuous at the specified value of x. So A starts out with a piecewise function. X squared plus 1 if x is less than or equal to 0, then f of x equals x squared so there's the piecewise function. Looks like you have some kind of transition when x is 0. And now what they want to determine is this function continuous at x equals 0? In other words, continuous functions mean, remember we said if you draw a graph, continuous function means you can draw the whole function without lifting your pen off the paper. So a non-continuous function would be something like this, or maybe you have a hole where you have to jump over that, and then you keep going. You could have a function where it's like this, and then you make a jump, and you keep going. Basically, continuity is checking for gaps or breaks or jumps in your function. So here's the example sort of visually, but mathematically, it's actually pretty straightforward, because here's what you do. Okay, just to show you, say I've got a function, and I want to check the continuity when x is equal to c. All you do is you take your function and you actually plug in that number into your function. And you also take your function and determine the limit as x approaches c. And if those two are the same, if they're equal, then it is continuous. So basically, the point you're checking, you just evaluate the function, and then you go take the limit of the function at that point, and if those happen to be the same, you have a continuous function. So in our case, we're only to check when x is equal to 0. So let's first say, what is f of 0? You just take your function, plug in the number for x, and determine what the function is. Well, I got a piecewise function, so I got to figure out, so when x is 0, this first one's for less than or equal to 0 and greater than, so it looks like it's the first one. So it's 0 squared plus 1. Looks like it's 1. So the function at 0 equals 1. Now let's go find the limit as x approaches 0 of f of x. Now remember, to find a limit, you have to approach it from the low side and the high side, and they have to be the same. So if I approach it from the low side, when I plug in, I should actually show this. Let's say when you approach it from the low side, it's going to be x squared plus 1. It's going to be 1. If you approach it from the high side, you end up using the second equation. Turns out we don't even have a limit. There's no limit. Therefore, obviously, it can't be equal to our function. So we say it is not, that function is not continuous at x equals 0. And just for fun, if we look at it, it'd be pretty obvious if we were to graph it. Just for fun, maybe I'll do it real quick. I think it's pretty simple. If we were to graph, it's like y equals x squared. But then y equals x squared plus 1. Looks like this. But the thing is, it's x squared plus 1 for x less than or equal to 0. So it's almost like and then it's x squared when it's greater than 0. So here's that function. So yeah, when we look at x equals 0, is there a gap or a jump? Yep. So that just confirms what we found mathematically. All right, there's a couple more. B says f of x equals x plus 1 over x minus 1. And they want to know about the continuity at x equals -1. So what you do is you first evaluate the function at -1. It's like 0. And then you say how about the function as x approaches -1? So what you do is at the first go to find a limit, you plug in -1, and as long as nothing bad happens, it's okay. So you plug -1 plus 1 over -1 minus -1. Now it looks like f of -1 equals 0. The limit as x approaches -1 of f of x is 0. Since it's the same, we say that function is continuous at x equals -1. It looks like there's one more example. Actually, it looks like it's the same equation. So we're going to check the continuity at x equals 1 instead of x equals -1. Well, you do the same thing. F of 1 plus 1 over 1 minus 1. Okay, what happens? I don't even need to do anything else because obviously my function is undefined. And I'm checking to see if my function equals the same thing as the limit of the function. Well, it doesn't really matter. This is undefined. So it's not continuous at x equals 1. All right, so that's checking continuity. Now we're ready for number 9. And number 9 is going to take a little bit of work, so let me stop now and continue on the next video.